Hey YouTube, Never-Ending Student here, and I've got a little repair for you. So, as trapped as we all are by the locked-in battery ecosystems of, power tool brands, I've swallowed the red pill and gone Milwaukee, and I've been mostly satisfied with that choice. I really wish we had good quality adapters. We do have battery adapters now. That's probably an issue for a separate video, which I'm looking forward to those getting to the point where they can translate battery management communication between tool brands. Anyway, different tool brands do different tools the best. Milwaukee has some excellent stuff. DeWalt has some excellent stuff. Rigid, Makita, they have some excellent stuff. And it kind of goes back and forth as to, like if you look at the torque test channel, different tool brands will, get on the top of the hill for a specific tool and keep it for a bit. There's at least some competition going on. Anyway, I digress. What we have here is a Milwaukee circular saw. This is the Milwaukee Fuel 2730-20. Yeah, I think you can see it there. All right. Anyway, there's a semi-common issue that happens with this, and that is the trigger. The contacts kind of carbonize and fail, and then when you go clicky, it not go burr. So, there's a few things you can do. You can buy a replacement trigger, and disassembly and getting to that trigger is not a big deal. You need, a T15 Torx bit, a T20 Torx bit. I don't think you need security Torx. I think it's just regular Torx. And then you open it up, and there's 4 Phillips screws to remove the trigger assembly. I'm going to take you over to my computer now to show you the part number you need to order if you want to just wholesale replace it. So that right there, 23-66-0098 or 1269.0625. That's the correct model replacement switch. This is currently the best price I'm seeing on eBay. I've seen it like 25 or 26 before, and that's with $5.50 shipping. So, the total here is like $23.50. So that's not a bad price at all for a replacement part. I decided I wanted to just invest more time, use it as an opportunity to make some content and repair it. So, let's take you off shaky cam. All right. So I can show you what happens. If you want to take apart the module, it's just clip-on. You take a flathead screwdriver, 1, 2, 3, 4, and it pops off. Just a tip for this assembly. It'll look like this when you take that off. I recommend, for your own peace of mind, you not futz around with this. This spring is underneath there, and it will spring out at you. And it is, I'm sure I'm going to be able to get it back together, but it's an absolute pain in the ass. I've tried, I've failed many times. So it's a real finicky kind of, you need 4 hands and pixie-sized fingers to get everything together. Whatever. It's the thing you have to futz around enough with and get small tools to finagle it together. The spring keeps wanting to pop into a wrong position. Moving on. So if you take this out, what you end up with is, this is the outside. So you unscrew these, and in there is the inside. And it's just a couple different contacts that gets bridged. And this is the other side of that. and I'll show you on the microscope. Okay, so you can see there let me get a little pointy stick. And it has little cat hairs on it. Anyway, you can see tiny bits of dark right there. That's really not bad at all. But let's take you over to the lower one. Lower this guy down. And you can see the bottom section is more pronounced. You can see the charring and carbonization there, and where it's kind of arced on the metal. So the other side of this equation, let's take this off. Oh, and there's a spring here, so like, you know, careful not to pop that out. I love this OmniFixo so much. Such a good tool. All right. So let's zoom up. Now these are the reverse side of the contacts, and you can see in there, so that's, you know, much more carbon, much more like kind of sputter all over it. And then we'll take a look at the, let's move this up, I guess. Yeah. And this is the area that's not as bad. We'll go and focus down in there. And there you can see, this side really isn't the problem side, it's the other side that is. You can see there's some carbon, some scoring on these contacts. And ideally these are, you know, a high temperature resilience silver alloy, ideally. Or if you want to get into like really unobtainium specs, you could use one of the platinum group level or metals like osmium or rhodium or platinum or whatever for super high melting temperature stuff if you're going for space applications. We don't need that for this, but I suspect there was an issue either of contamination getting in there, like maybe a little bit of the grease got on the contacts and that got thermalized and, you know, basically burned. Or it's just a matter of the designers decided to not really care if the mean time before failure, you know, was measured in a few thousand trigger pulls instead of a million or 100,000. Because ideally you'd like it to be pretty up there for, you know, the mean time, so that your 10% and your 1% outlier failures don't really happen to hundreds or thousands of customers if you're making like 100,000 of these tools within the first 6 months of their, you know, lifetime. But anyway, this is somewhat fixable, and I'm going to go get various different tools to try scraping at that or grinding it, and you'll get to see, you know, the difference of results and what works and what doesn't. So we're going to start off with a dental pick. Every electronics lab could use some cheap used dental picks. Is this one sharp enough? Yeah, I think so. Look for them on eBay in bulk. It's useful to get. So let's take a look. It is scoring. I think I'm not zoomed out quite far enough. Okay. All right. So let's see how much of that carbon scoring I can get rid of. It looks like some of it is just flash carbon, because it's not like I'm getting any felt feedback that I'm scraping away. Yeah, it really doesn't feel like I'm scraping anything more than soot. But in the center, there was what felt like a little bump, and I'm guessing that was actually a teeny little bit of arced off metal. And when you have that little bit of physical standoff combined with the carbon there, that's what was getting the trigger pull, and the contacts weren't making good enough electrical contact for the thing to run. So let's get a scraper that's... Actually, let's get a better read on how much of that is just going to come off with a wipe. So let's just take a regular Q-tip. I'm going to get some isopropyl on this. Just 70%, it's fine. And yeah, we have okay wetting there. So let's just give this a wipe. And I have some material that came off. Let's see if we can do a little bit better. What about this one? So I haven't scratched this surface yet, so I'm going to try just wipe with the alcohol. Yeah, it got some. Let's try a little bit more. And we do see improvement. Okay, so that got a fair bit of the carbon, and it kind of left us able to see where the actual either pitting or tiny bit of arced metal is, and that is what needs to be scraped. Now, most likely, if I plug this back in, it would just work now because we've gotten rid of enough carbon that we'd make contact. But while we have it open, there's no reason to not, do a thorough clean. And what do we have there? We have a teeny tiny bit of plastic there, it looks like. Just give you an idea of how small that is. Microsurgery tweezers. Yeah. I'll throw that away. Okay. So let's go ahead and finish wiping down the other contacts. These are the ones that are less pronounced. So I'm not really worried about getting good footage on those. You already saw they didn't have much on them. All right. So let's get a scrape there. So we already got scrape there. The center is, the contact area. So let's try to get that black off. I can feel the actual physical pitting there. Actually, no, it's not pitting. It's stuff on top because it's coming off. And yeah, you can see it scraping off. So after we get this scraped, at least down to enough bare metal, what we'll do is then do one more wipe down with isopropyl. Yeah. Let's just get a fresh Q-tip. And now you can see it looks like there's, yeah, probably just a teeny bit of metal shavings there. Oop. Bit more isopropyl than I needed. Whatever. So let's take a look and see if I get those shavings. It's all wetted with isopropyl, and now we'll wipe it dry with a dry end. And that looks much cleaner. Down here, yeah, we can do a little scraping there. So I'm using a moderate amount of force. And yeah, you can see that got that. Because when some of it feels flat and I don't feel any catch, that's when you do have to, push a little bit harder. And that's fine to do. All right, those are good enough. So now we're going to switch over to the other side of the contact. And yeah, this is, of course, the, let's go up a little bit. Yeah, that's good and in focus. So you can see there how much scoring we have in carbon, but it's mostly flash and arc stuff. So let's do a bit of, ooh. Okay, so this is on a spring here. So applying pressure there is a little more difficult. We do have a tool for this. So, grinding pen. And yeah, let's just get these. So this is basically like a Dremel, but it's specifically for electronics, and it has much lower force, which you want a more gentle hand when you're like grinding down the solder mask on top of a trace, and you want to expose the carbon, or sorry, I'm mixing up the two. You want to expose like the copper on a trace, and you don't want to grind through the copper. You want reasonably low RPM and low force. So oh yeah, look at that. So this does not apply much force at all. And we saw that just get rid of that bit of carbon and scoring there. And I'm not putting much pressure at all. There. So now let's take a look at these other contacts. These are the ones that aren't nearly as bad. And we'll do the same with them. Yeah. So the abrasive on this is not aggressive. The RPMs are low, power is low. And for this kind of thing where you don't want to ablate material off, You just want to, well, we are ablating, but you don't want to ablate much off. So you want very fine control to only take a little bit, the least amount possible. This is what you want. So let's give these a bit of a wipe. And these were the worst ones. You can see they're nice and shiny now. All right, so now we can reassemble that switch. And I'll pause here so you don't, well, maybe you want to see the reassembly. One sec, I'm going to readjust. All right, sorry. All right. Oh, actually, no, I am going to pause it for the whole thing because I have to get that pain in the ass spring back in, and you don't need to waste like 20 minutes watching that. All right, pausing. So I just figured out how to get this thing back in. So you can put the spring entirely in this piece that pops out, and that's what you have to do. But then when you close it back down, it won't go into the bottom slot. But the engineers who designed the mold have this little slot here. So you need something long, strong, flat, and thin to go in there and compress the spring down just a teeny bit, and then you can close it all the way. And now it's like that. Also, something I didn't get is there's this little fabric wipe, and that needs to be right in this indent to block soot and dust and stuff from getting in. So I need to adjust that a little bit. Pausing again. Okay, we have it reassembled. We're going to now just make sure that we have good contact. Go to annoying beep continuity. And all right, we can't get our probes in there too far because we'll jam the mechanism. Check the other side. Now, I'd love to put this back together and show you the saw power up, but strangely, gee, you know, we have 4 screw holes here. Somehow there's only 3 screws. Hey, jerk. Who stole screws? Bad foofy. Now, if this happens to you, as far as I can tell, and I don't have them in hand yet, so be aware I'm not absolutely certain, but I got out my caliper and, you know, use that. As best as I can tell from measuring the diameter, thread pitch, they should be M3.5 screws. They are M3.5 by 6 millimeter panhead Phillips. So I could have gotten like 10 on AliExpress for about $2.20, but instead, why get 10 for $2.20? Oh, this is the wrong link. When I can get 100 for $5.49. I'm set for the next 99 switch failures that I have to fix in combination with my cat stealing a screw. Yeah, now that's preparation. But, I mean, in this case, when it's like a couple dollars difference to get 100 of a material that you've already had cause to use versus one or a few, and it's really small, why not future-proof? I mean, really. So, yeah, we've already continuity tested. We know that the contacts here, man, that's an annoying click, like loud, sorry. We know the contacts are making good contact now because continuity said so, and yeah, that's how you fix this. It's probably good for another year or two of service. Maybe if we got enough of the crap off and kept it off, then it'll just work for the rest of its service life, given the small duty cycle I ask of these. And yeah, that's how you fix that switch if you don't want to replace it. Have a good day.